Physics friends, hopefully you guys made it through that one step by step by step. We're going to take another look at another problem. This is the second one that you've got on your sheet. As you notice, it is a mystery box problem. It's labeled, as you guys will love, I'm sure, friction and angles. Oh my, it's all of our favorite things together at the same time. In this question, it says that a 10-kilogram box is pulled along a horizontal surface with an applied force of 40 newtons at an angle of 30 degrees. So now we've got an applied force at an angle, which I know is going to make you all super happy. So this is kind of like the problem that we did earlier with the same kind of situation, except now we've got some kinetic friction acting as well. It says here that the coefficient of kinetic friction is 0.3. So just like any of these problems, we're going to start off by drawing a picture. So let's draw ourselves a picture of our mystery box. Here it is. Still don't know what's in it. You guys haven't decided. So let's draw the forces acting. We've got the earth pulling down. That's gravity. We've got the floor pushing up. That's my normal force. And again, I care about normal force now, right? Because I've got that frictional force that's pushing as well. I've got an applied force that's happening at an angle, and that's fun and interesting. We'll have to get through that again, and we will in just a moment. An angle of 30 degrees, and that's the force of the person on the box, Fp, oops, P. And then we've also got a frictional force, and the friction, I didn't say this before, so let me write this down, or let's say floor on box, FF. The nice thing about friction is that friction will always run parallel to a surface. So hopefully you remember that we said that the normal force will always run perpendicular to a surface because normal means perpendicular. The frictional force will always be parallel to a surface. So that's kind of a nice thing to keep in your head. Okay, so we need to figure out, let's see, we're trying to figure out the acceleration on this box. And in order to find the acceleration, because the acceleration is only going to be in the x direction, we'll need to determine what the total forces are in the x direction and use that to find the acceleration. As you may have guessed, we get to break our person on box force up into two components, two pieces. And I'm going to walk through that again just because it's been a little while since we've done it. And I want to make sure that we're doing okay. So I'm going to draw one part, Fp. I'm going to write that in the x direction, Fp in the x direction. And then I've got Fp in the y direction. So that's the part that's going up. And that will change the normal force, which is why we really want to pay attention to it. So to remind ourselves about this triangle business, we're going to remind ourselves that the total force is the hypotenuse. And I want to pay attention, let's do to the y first. So I'm paying attention to this one right here, Fp sub y. That is the opposite side of the triangle. And so then I can say, okay, SOHCAHTOA, opposite over hypotenuse, sine of theta is opposite over hypotenuse. So that means that I can say that the sine of 30 is equal to the thing I want to know, Fpy, divided by Fp, the thing I do, and that's the hypotenuse. And so from that, I can say, and I will say that Fpy is equal to Fp times the sine of 30. Okay? And I can figure out what that's equal to. I'll let you guys do that. Check with each other, make sure you agree. I can do the same thing for the x direction, except that the x part is going to be the adjacent side of that triangle. So we're going to say SOHCAHTOA again to ourselves, and now we're talking about the adjacent and the hypotenuse. That's ka, which is the cosine of theta, is equal to the adjacent divided by the hypotenuse. So we can say then that the cosine of 30 degrees is equal to FPX divided by FP. Or one more time, because we like to just keep rewriting it to make it more clear, FPX is equal to FP times the cosine of 30. Plug those values in, and then you can find that one as well. Okay, now to actually solve this problem, right? We need to write down some FNet equations, I think, some summation equations. We all know what those mean, right, ladies and gentlemen? Yes, Miss Cobbling, we love them. All right, here we go. So let's write down some FNet equations. Here they come. So FNet in the y direction, let's write down all the things that are pushing or pulling in the y direction. I see Fn is pulling up, or pushing up, I should say. I've got FPY also pushing up. And I've got FG, which is pulling down. So I'm going to make that negative just so I don't forget. And in the y direction, that box is not accelerating up or down. So I'm going to say it's equal to 0. From there, then I can solve for Fn. That's going to be Fg, the positive value of it, minus Fpy. So I'm going to subtract those two values to get myself Fn. Okay. Again, I'm not going to go through all the numbers. I'm going to let you guys do that. Talk to each other. You can pause the video, of course. And once you've got a value, then we'll keep cruising. In the x direction, now we can figure out the acceleration. We had to do the y stuff in order to figure out Fn because, as you might remember, the friction force depends on the normal force. So let's write out that Fnet equation. Fnet in the x direction, what have I got acting? I've got Fp in the x direction. That's the force of the person pushing on the box. And then I've got the force of friction that's pushing in the other direction. Okay. These are going to add up to something. They're going to add up to the Fnet, and then using that, I can find the acceleration. A is equal to Fnet in the x direction over m, because it's only accelerating in the x direction. Fpx is a value that we know. That's what we have from up here. Okay. And Ff is going to be mu, that value that we had up here, 0.3 times Fn, the value that we have from over here. Okay. So you're going to plug in some values, find your Fnet, and then use this equation here to find acceleration. There was a lot of stuff in this video, and if you need to go back and watch it again or rewind it, whatever you need to do, go ahead and do that. But hopefully these two pieces will help you get through this problem. We will pick up pieces as we need to on Wednesday and Thursday, but I'm hoping that this will get you started. I hope you have a great day, and I will see some of you on Wednesday and hopefully all of you on Thursday. Take care, guys. Bye.